Welcome to part 4 of the Module 9 exam review. So we're picking up at number 19. We have 3 equations and 3 unknowns, but notice this first one only has x's and y's. So I'm going to put this over here, x plus y equals 0. And then I'm going to use the second 2 equations to get rid of the z, so we have 2 equations with both x and y. So I can just visually add these together. X and our 3x is 4x, so I'll write this over here. Negative 3y plus y is negative 2y. The z's cancel, and then 0 plus 0 is 0. So looking at these over here, I'm just going to get rid of the y's by multiplying the first row by 2. So that gives us 4x plus 2y equals 0. Add these up, 8x, the y's cancel, 0 and 0 is 0, divide by 8, and we get our x coordinate to be 0, so x equals 0. So to find our y, we can plug this back into this equation here. 2 times 0 plus y equals 0. That cancels out, so we get y equals 0 as well. And then plugging those in this middle equation right here, 0 minus 3 times 0 plus z equals 0. So we're doing that to solve for our z. That goes away. Z equals 0 as well, so the solution to that is 0, 0, 0, 0, 0. Okay, so looking at this next one, number 20, we have the sum of 3 numbers is negative 6. I'm going to say the numbers are x, y, and z, so we can just say x plus y plus z equals negative 6. That's totally fine. Now the first minus the second, so x minus y. So we're assuming that y is the second now, plus 4 times the third, 4z is negative 13. So from the second line, x is the first, y is the second, z is the third. So that's how I've set this up. Now the third sentence goes on to say the third, z, plus twice the second, so we have 2x, plus twice the first, plus the second is negative 8. So here, just taking a minute to look at these, it looks like if we add these two together, the y's go away. If we add these together, the y's go away. So I'm going to eliminate the y's. So x and x gives us 2x. Now z plus 4z is going to give us plus 5z, and this equals negative 19. And then adding the second two, x and 2x is 3x, the y's cancel, 4z and z is 5z, and then negative 13, negative 8 is negative 21. So over here, it looks like the z's are probably the easiest to get rid of, so if I multiply the top row by negative 1, we have negative 2x minus 5z equals positive 19. Add these up. X, z's cancel, equals negative 2. So our solution is negative 2. Something, something, something. To get our z, we'll go ahead and substitute in here. So we have 2 times negative 2 plus 5z equals negative 19. So negative 4 plus 5z equals negative 19. Add 4. And we get 5z equals negative 15, divided by 5, and we get z equals negative 3. So our z equals negative 3, our x equals negative 2. Go ahead and plug it back in the very most original top one up here to get our y. So we get negative 2 plus y minus 3 equals negative 6. So y minus 5 equals negative 6. Add 5. And y equals negative 1. So the solution of that, negative 2, negative 1, negative 3. Okie dokie. Now, let's look at the next one. The next one, some people must eat a low sodium diet with no more than 2,000 milligrams of sodium per day by eating 1 cracker, 1 pretzel, and 1 cookie. So we have crackers, pretzels, and cookies. I'm going to say X is sodium in cracker. Y is sodium in pretzel, and Z is sodium in cookie. Okay, so it's not the number of crackers, pretzels, and cookies, but it's the amount of sodium because we're equating these via sodium. So it says by eating 1 cracker, 1 pretzel, 1 cookie, so X plus Y plus Z, a person will have 149 milligrams of sodium. If a person eats 8 pretzels, so 8y, and 8 cookies, 8z, they're going to get a grand total of 936 milligrams of sodium. Okay, and then by eating 6 crackers, so that's going to be 6x, and 7 pretzels, so 7y, they're going to get 535 milligrams of sodium. So those are the equations. Now, I'm just going to pull the second one over to the side. 8y plus 8z equals 936, because that has y's and z's, meaning that I'll use this first equation and the third equation to get rid of the x's. So if I multiply this by negative 6, we have negative 6x minus 6y minus 6z equals, and now 149 times 6 is going to give us negative 894. So let's add these up. X's go away. We have a y minus 6z equals negative 359. So we'll put this up here too. So we have y minus 6z equals negative 359. Okay, so here what I'm going to do is I'm going to go ahead and eliminate the z's because they're of opposite signs. Plus, when I think about the lowest common denominator, or least common multiple of 8 and 6, it's 24. So if I multiply this first row by 3, we're going to have 24y plus 24z equals 3 times 936 is 2808. So if I'm multiplying that by 3, I have to multiply the second row by 4. So we get 4y minus 24z equals, now 359 times 4 is 1,436, and that's negative. So then we add this to our, so we add them up. So when we add these up, 24 and 4 is 28y. The z's go away, and then this is going to be 1372 divided by 28, and we get y. So if we divide by 28 here, we get y is 49. So that tells us y. Now y is the number of sodium in pretzels. Now we're supposed to answer this question, which of the following is true? A pretzel has 49 milligrams of sodium? Well, we just got a pretzel has 49 milligrams of sodium, so the answer is A. Now if that wouldn't have been true, we would have wanted to plug this back in here to get the z to find out how much is in a sodium in a cookie, and then if that wasn't true, we'd want to plug our y and our z back into something over here, probably that one, to find out what x is, the amount of sodium in a cracker. One of those is going to be the answer. It just so happens we found it a little bit before before I actually thought we would. So at any rate, the answer to that is A. So now for the last one here, let's do 22 and 23 and then we'll be good. So the sum of the ages of Art, Ben, and Cal is 59. So we'll say Art is A, Ben is B, and Cal is C. The sum of their ages is 59. Now, it says Art is 1 year older than Cal. So Art equals Cal plus 1. Because Art is older than Cal, we have to add something to Cal's age to get Art's age. Then finally it says Cal is 1 year younger than Ben. So Cal equals Ben minus 1 because Ben is older than Cal. If we take 1 away from Ben, we're going to be good. Okay? So one thing that we can do is, because this says A equals C plus 1, in this equation we can plug that in and say we have C plus 1 plus B plus C equals 59. And then I'm going to combine like terms and get this in standard form. So I'm combining my C and C. So we have our B plus 2C, and subtracting 1 equals 58. Okay? Now, if I take this third equation, because I used this equation came from the first and the second, so I need to use a different equation now. So if I move the B over to the left side, we have negative B plus C equals negative 1. Write that over here. Negative B plus C equals negative 1. Add these up, the B's cancel, so we get 3C equals 57. Divide by 3, and we get Cal equals 19. So Cal is 19. Now, right here, Art is a year older than Cal, so Art is 20. And Cal is 1 year younger than Ben, so if you add 1 to Cal's age, Ben is also 20 years old. So that's the way that one works. So hopefully that makes sense. Now the last one, it says a basketball field house seats 15,000 people. Courtside seats sell for 9, end zone for 7, and balcony for 5. A total for a sellout is $91,000. If half of the court side and balcony and all of the end zone are sold, the total is $52,500. So C is going to be the number of courtside seats, E is going to be the number of end zone seats, and B is going to be the number of balcony seats. So there's 15,000 seats, so we can say that C plus E plus B equals 15,000. Number of seats plus number of seats is number of seats. Now we're going to talk about the sellout. If we sell all our courtside seats at 9, that's 9C, plus all our end zone seats at 7, that's 7E, plus all our balcony seats, that's plus 5B, we're going to get a total of $91,000. And then finally it says if half the courtside are sold, so 9 times C over 2, because half of the courtside would be C over 2, and half of the balcony, so 5 times B over 2, and all of the end zone, so plus 7E, we would get 52,500. Okay, so first thing is I don't want any fractions, so I'm going to multiply this third equation, everything by 2. So here when I do the 2 there, it cancels with that and that, so we have 9C. The 2 here turns into plus 14E. The 2 here cancels with that, giving us plus 5B. And then the 2 here was going to give us 105,000. So now we're no longer using this equation. We're going to use the one with no fractions. And if I look right here, C and B would cancel off nicely if I just multiply this by negative 1. So negative 1 times that's negative 9C minus 7E minus 5B equals negative 91,000. So here the C's cancel. 14E minus 7E is 7E. The B's cancel. And right here, when we subtract this off, we get 14,000. Divide by 7. And E equals 2,000. There's 2,000 end zone seats. So then, because we have one of the variables, we can plug those into a couple of them up here. So I'm going to plug them into this one, this one, and this one. So I can say C plus RE, which is 2,000, plus B is 15,000. And then I can say 9C plus 7 times 2,000, plugging that in for E in the second equation, plus 5B equals 91,000. Excuse me. So we've substituted this E into both of these equations for E, rewritten them down here, and now we just have two equations with two unknowns, and we know that E, the number of end zone seats, is 2,000. So here I'm going to move the 2,000 over, subtract 2,000, so if C plus B equals 13,000. Here, that's really a 14,000, so I have 9C plus 5B. If I take 14,000 away from 91,000, we're going to get 77,000. So now I'm going to eliminate the B's here, so I'm going to multiply this by negative 5. So negative 5C minus 5B equals negative 65,000. Add these guys up. 4C, B's cancel, equals 12,000. Divide by 4, and C equals 3,000. So there's 3,000 courtside seats. Okay, now finally to get the number of balcony seats, we can use this top equation. We got courtside, so 3,000 plus 2,000 plus B equals 15,000, or 5,000 plus B equals 15,000. Subtract our 5,000. And B equals 10,000. So there's 10,000 balcony seats. So that's that one. So hopefully this made sense. Next time we are going to have we're going to start on the inequalities, the compound inequalities, the and inequalities, and then we'll see where we go.